I'm Casey Cantwell, and I work for NOAA's Office of Ocean Exploration and Research, and I'm the expedition coordinator of the Okeanos Explorer Mountains in the Deep expedition. The overall goal of this expedition is to get a good first look at a number of the deep sea habitats that exist throughout the Central Pacific Basin. Specifically, we've been focusing on seamounts. So the Central Pacific Basin is largely unknown, and we understand so little about these seamounts that populate a large chunk of the seafloor. So when we've been moving the ship from American Samoa up to Honolulu, we took advantage of the opportunity to explore some very remote regions and to map and then conduct ROV dives on a number of seamounts that we have very little information about. We're exploring the Pacific Ocean seamounts because they're so largely unknown. We don't even know what they look like in a lot of cases.
When we come out and we first start looking at this area, we're looking at very coarse resolution maps of the seafloor that have maybe a data point every kilometer or something. These are generated with satellite altimeters that are really using gravity to infer what the shape might be. And we get there and we look at it with the shipboard multi-beam, we're like, holy cow, this is not what we expected.
So sometimes, on the seamounts we've been diving on, some of them had data and some of them didn't have data. And the ones that didn't have data, we're mapping the night before. And sometimes when we map them, we could say, okay, well, we want to get to the seamount based on this altimetry data. We think it's, 3,000 meters high or 3,000 meters off the seafloor. Well, we get there and it's only 2,000 meters high. Well, all of a sudden our dive has now changed 1,000 meters in depth, so now we're diving in a totally different region as well. So this is why we do the mapping, because you never know exactly what you're going to see down there. And, we've seen several times on this expedition so far, kilometers in difference of what we thought how high these seamounts are going to be.
Every time that we get a little bit more information about them and we're able to put together a better picture, a higher resolution map, we learn more about what a seamount is, what its history is, and what potential communities live on them. So once we have a map, we're able to pick a dive target. We then take our remotely operated vehicles and go down and explore the seafloor. While we're there, we're able to collect high-resolution detailed imagery to specifically target in situ observations of lava flows, of eroded carbonate. You can learn a lot from just by looking at the rocks.
And then we'll go down, the shipboard multi-beam is giving us a depth reading every 70 meters or so, depending on how we're gridding it. And we go down with the ROV and we start looking at things on sort of meter by meter or a few meter scale, and we see all sorts of relief and topography that don't show up in that data. We've been able really to see some clear volcanic features in some of these seamounts. We saw spectacular kind of collapsed lava tubes in one. So there's this record of these things that went on tens of billions of years ago that we can go down with the ROV and look at today, which is just amazing.
In order to figure out how these seamounts formed and to get more information about how old they are and what their history is, we have to collect a rock sample. So once we collect a rock during an ROV dive, we bring it back to the surface, we dry it, and then we prepare it to be sent to a museum or a public repository where the science community can then access it and begin the aging and dating process.
We want to sample rocks for a couple of reasons. One, we can look at their geochemistry, and we can compare it with the geochemistry of other rocks that tells us if those lavas might have had a common origin. The other is we can use radiometric isotopes to actually date a rock. So when a rock forms, it takes in certain elements, and some of those elements change through time at a known rate. And then we can use that to constrain the age of the rock. So we did get a couple of small rock samples, and we hope we'll be able to do geochemical analysis as well as get an age date from those rocks.
So one of the most exciting things about this expedition is that we're able to get a first look at a lot of these seamounts. We map them for the first time, and then we're able to conduct ROV dives and see the first ever in situ observations on the seafloor. We then can collect biological and geological samples, which give us an opportunity to learn more about the communities as well as date the volcanic features.
All of the mapping data we collect, all the ROV footage, all the rock samples, the biological samples, scientists from all over the country and all over the world will have a chance to actually use these data. And a whole lot of people will use this down the road, and that's really an exciting way to do business, I think.
And being able to explore at those different scales all within 24 hours, going from a totally unknown seamount to a seamount that has beautiful images and biologic and geologic samples, we're happy to support that, and we love doing it. And that's sort of exploration from the ground up, right?